Hello everyone, welcome to Brain Blitz Audios. Today we'll be discussing about NCERT textbook solution on the subject mathematics. Today we'll be covering exercise 6.1 of chapter 6, that is the triangle and its properties, in class 7. Let's begin, shall we? Question number 1. In triangle PQR, D is the midpoint of line QR. Line PM is, PD is QM is equal to MR. Now, to solve these questions, let's look at what are altitude and median. So, altitude of a triangle in geometry is the line segment that connects one vertex of a triangle to the opposite side perpendicularly. Let me rewrite that. Perpendicularly. Now, perpendicularly means that it intersects at 90 degrees. So what this means is that, for example, consider this. So this is point A, point B, point C, point D. Now, in the diagram I have drawn, AB is perpendicular to CD. It forms a 90-degree angle at where it intersects at both the sides. That is what is called a perpendicular line. So, now let's look at what is a median. A median is a line segment that connects a vertex of the triangle to the midpoint of the opposite side. Now, the midpoint is that if we divide one of the sides by 2, for example, a side is 6 centimeter. If we divide by 2, it's 3 centimeter. So at 3 centimeter, if we put a point, that would be the midpoint of one of the sides. So line segment that connects the vertex to the midpoint of the opposite side is called the median. Now, let's look at the questions. Line PM. Now, line PM intersects with line QR. Now, if you look at it carefully, we can see a right angle right there. So, PM intersects to QR at a 90-degree angle. So, that means that PM is perpendicular to QR. And in triangle PQR, QR is one of the sides, and the opposite of QR, the remaining vertex is P. So PM. So that means that PM must be the altitude, because an altitude is the line segment that connects one vertex, that is P, in this case to the opposite side, that is QR, perpendicularly at point M. So PM is the altitude. Now let's look at this next question. PD is. Now in the question is given that D is the midpoint of line QR. So if QR is 10 centimeter, then QD and DR would be 5 centimeter. It is in the middle. So PD. Now P is the remaining vertex other than QR. So if PD is connecting P to D, the line, it's a line segment that connects one vertex to the opposite side and at its midpoint. So PD is the median. P is one vertex and D is the midpoint, so PD is the median. Now let's look at the next question. Is QM equal to MR? Now for this, let's look at QM and MR. QM and MR, M is at the middle. So for this to be true, M must be the midpoint. Midpoint of what? So midpoint, if we remove M, we get Q and R. So the midpoint of QR. But this is not the case. If we look at the question is saying, has already given us that D is the midpoint of QR, not M. So this is false. So that means QM is equal to MR is also false. So QM is not equal to MR. Second question. Draw rough sketches for the following. In triangle ABC, BE is a median. So let's draw a triangle. A rough triangle. So let's say these are the lines of the triangle. Now let's name the vertices. This will be A, B, C. Now in the question it's given that BE must be the median. Now B is already the vertex, so, and the median is the line segment that connects one vertex to the midpoint of the opposite side. So E must be the midpoint of the opposite sides. So E must be in the middle of AC. So let's say that is point E, and this X is X and 2X totally. So we have to draw the median BE. So if we connect it, we get the median. So BE is the median in triangle ABC as per the figure we have drawn. So that is the answer for this question. Next question. In triangle PQR, PQ and PR are altitudes of the triangle. So now let's look at the sides of triangle PQR. Now in triangle PQR, the sides must be PQ, QR, and PR. Now the question is also saying that PQ and PR are the altitudes of the triangle. So that means that the altitudes of the triangle, at least two of them, are two sides of the triangle. So let's draw. So if this is one altitude, they must intersect at 90 degrees. So there must be a line over here. Now we can't extend it both ways, only one ways, because it is a because if it went both ways, then the altitude we drawn would be inside the triangle, not a part of the sides of the triangle. So if we draw like this, now this forms two sides. So if we just connect these vertices, we get a triangle, more specifically a right triangle. So let's name the points. So we see that PQ and PR are the altitudes of the triangle. It's given the question, and the common vertex in both of these sides is P. So that means that P must be, so triangle PQR must be right angled at P, and Q and R in the other sides. Now this is correct in this case, because if we see PQ, it is intersecting at a right angle in PR. So PQ is an altitude, and if we look at PR, we just look at it sideways, you can see that it also intersects at the right angle, the same right angle of the same right angle. So that PR is also one of the altitudes. Now there can't be two different right angles in a triangle, because 90 plus 90 is equal to 180, but all of the sides must be equal to 180. That's not possible. So in this diagram we have drawn PQ and PR are the altitudes of the triangle. Let's move on to the next question. In triangle XYZ, YL is an altitude in the exterior of the triangle. Now YL is the altitude, so, and Y is a part of the triangle. So let's draw point Y and point Y at the top, and if we draw a straight line, since YL is the altitude, it will be L right there. Now this must be in the exterior of the triangle, so we mustn't overlap this. We mustn't use YL as one of the sides. It's XYZ. So if we draw like this, name it that point as X, extend this right as Z, and right there. If we extend XZ, YL would be intersecting with XZ. So that means that in an obtuse angle triangle, one of the altitudes would be the exterior of the triangle. So it is true in this case. It is true in this case because YL is outside of XYZ, and it forms a 90-degree angle. So we have solved this question. Let's move on to the next question. Third question. Verify by drawing a diagram if the median and altitude of an isosceles triangle can be the same. So first, for solving this question, we need to know how to draw a perfect isosceles triangle. So first, let's draw a side. So let it be side. So let's name both of the points as AB and let this measure to 6 centimeter. Now in an isosceles triangle, two sides must be equal. So let the two sides we are about to draw be equal. So say it is 8 centimeter. Now using your compass at point B, measure it by 8 centimeters. So 8 centimeter, measure, widen the compass to 8 centimeter using a ruler. So it will be right there. And we also put the compass. So after we draw, so from point B, we have to draw an arc using the compass. So if we draw an arc, it will be almost like this. And now do the same to the other side. At point A, we put the compass and widen it by 8 centimeter, and then we draw an arc. This is called an arc. Now the point at which they meet, this would be the third vertex, C. Let's name it as C. And if we join AC and CB, we get a triangle, an isosceles triangle. If we measure it, both of these sides would be 8 centimeter. Now, so if both of these sides are 8 centimeter, now let's verify that the diagram, that median is equal to altitude. Now let's divide AB into two parts. So let's name the midpoint as D. So AD would be equal to 3 centimeter and DB would also be equal to 3 centimeter. D is the midpoint. If we draw a line from C to D, then it is one of the vertex connecting the midpoint of the opposite side. So DC is the median of ABC. So DC is the median. Now, if we look at it carefully, DC also intersects to AB at a right angle, a 90-degree angle. That means it is perpendicular. It is perpendicular to AB. CD is perpendicular to AB. And C is also a vertex and it's connecting to the opposite side and intersects at 90 degrees. So DC is also the altitude of ABC. Since DC is perpendicular to AB, and we have proved that DC is the median and the altitude of AB, altitude of an isosceles triangle. So the median and altitude of an isosceles triangle can be the same. Thus verified. That's all, folks. We hope you found what you were looking for. For more such videos, please subscribe to our channel, Brain Blitz Audios. Until the next video, take care, stay safe, ta-ta for now.